Welcome, data people. We are Zuma. My name is Matt, and this is Data for Good. This podcast is brought to you by Zuma. Zuma is a dedicated recruitment company for senior data, insights, and analytics professionals, connecting you with Berlin's most influential companies. The Data for Good podcast is for the world of data analytics and engineering, giving you access to the thoughts and opinions of Berlin's most successful data people. Today, we are joined by Yev Petrov, Senior Product Manager at SumUp. Now, we're looking forward to this as we're going to cover some interesting topics around machine learning, and Yev is going to talk us through it and how we can bring it all to life. Yev, welcome. How are you?
Thanks, Matt. All good. And my name is Yev. I'm a product manager for our machine learning data platform in SumUp. And we cover all the machine learning use cases, especially on the risk and compliance side, and everything which brings great experience for our customers.
Amazing. So we can start there. Let's talk machine learning. It's an area that you have a huge passion for. First of all, for all our listeners, what is machine learning?
Machine learning is basically an application. It's a subset of artificial intelligence, and machine learning is the actual application of it within real life scenarios. So it's when you have some set of data that you want to train on your algorithm that wants to make some prediction on the future. So for example, if like in our use cases within SumUp, we observe that there is some fraudulent behavior happens within transactions, then we use this data and we use all the information associated to it to put it within machine learning algorithms, and then they make prediction for the next transactions that come in, if it's potentially fraudulent or not, already by knowing and learning on the previous experience. And there's many different applications of it, and maybe we can also dive into that if you're interested.
Amazing. So it sounds like it's getting all the data from what's happened in the past and using that to make the best predictions possible moving forward.
Exactly. So you need to have also a good basis for data platform for such reason as well. And sometimes there's some companies, out there that already have a lot of pre-calculated data and data of different customers. So they also provide it as a service to other companies. But in a nutshell, as more data you have, that's why right now it's very interesting space to be in, because so many companies are growing and there's many scalable startups and many big companies that also have a lot of data, and it's kind of like increasing in number of it. And the question is how to use it to its full potential and to full extent. And that's where machine learning is basically the ultimate driver of value of such big amount of data.
Yeah, we're hearing that more and more, the unfulfilled potential of data and how we can really utilize it to predict, improve, evolve almost all the structures that we have in place. So for someone who hasn't been exposed to machine learning, what are some very simple applications to help them understand it?
Mm-hmm. And maybe I will start with something that many people already familiar with. So if you use Netflix, you have you go to your homepage and you see all of the series, all of the videos that are suggested to you. But how are they suggested? And usually they're suggested based on the behavioral data that is used by machine learning model that is trained on some of the information that it already observed from the past. So it knows that people that already watched and binge watched, Real Housewives, they will probably also like to watch something like Bling Empire or Kardashians, and they will suggest them such information as well. And that's one of the applications, for example, of machine learning, which is this personalization and really driving the great experience for customers. And that's what we also do within SumUp, and some of the interesting use cases that we already explored as well is, as we within the company are focused on small businesses and we want to make sure that they have all the possibilities to grow their business. And one of them is coffee shops, which is kind of a big subset of merchants, and we explored how we can leverage machine learning to improve the experience of coffee shop owners and people who work within coffee shops. And SumUp provides the hardware devices, so it's where you collect orders and also where people can make payments with as a payment terminals. And we thought, can we really create assistant for merchants? So it would be a personalized assistant that can take these orders, they can communicate between merchant and the customer. So then the actual person who is working there can focus on what they love the most, which is making coffee, I don't know, like talking to customers, but not really interacting much with the like cashier system, like POS system. And that's where we created Solo as our smart personal assistant for small merchants. So then you can just say like, hey, Solo, charge for cappuccino and I don't know, like cookie. And then it will recognize it because there's machine learning model that basically translate the voice into text and into commands. So then it creates the experience as it reconfirms like, oh, charging for, cappuccino, and then it initiates the payment. So it does everything. So you don't even need to touch the device. So it creates a great accessibility feature for merchants. And at the same time, they continue doing their coffee, they don't need to even like go to the cashier, and then the whole process already done, and then they just interact only with the customer in this case. And that's just one of the applications how machine learning is leveraging and improving the experience of our customers.
Nice. So it sounds like to most people, we're exposed to machine learning, and you gave a great example about Netflix and how we're going to evolve that to even more personalized applications from day to day. We've probably been a bit spoiled by companies such as Apple, Netflix, Amazon, that it's just part of our day-to-day lives without noticing. However, there's a lot of work that goes on behind the scenes. It's not just an additional feature that we're adding on.
Exactly. And maybe just to add to that, because I totally agree. And I think that it's more about driving the best experience for customers, as I mentioned, but it almost like, works like magic. It's, something very easy, smooth, and it really improves the experience. So then you don't need to like, let's say like also with the example of Netflix, like go to like different categories of movies and try to like categorize yourself, find, what's the next like best thing to watch, because Netflix would already like know what you would like to watch. So then you don't even need to like navigate anywhere and like really like, and it simplifies the experience for customers, and it feels very easy. On the background, it's more complex than, it is like on the outside. And that's the goal. Like the goal is to really like delivering the best experience for anyone who's interacting with any part of the system. So it's as smooth as possible for them, but it's a challenge for us, but it's good at the end for the customers.
Challenge indeed. So where's best to start? Do we start with the customer problems and work backwards, or do we prototype more simple applications to see if it works before pushing it further?
I would say the best is to start with a problem. So problem statement, what is actually the problem like that we are trying to solve, and like why machine learning is the way to like approach it. And for example, as I mentioned, like one of the use cases that we had and explored is the one around like accessibility and really like creating this communication channel with the device, because oftentimes people are doing something, they're cooking with their hands, they cannot even like touch the device, and it becomes like very hard for them. And then it becomes a question like how to approach it, right? So then in the question like what is the best way to like solve it, and oftentimes there's just no better way to like really create this experience and improve this experience and really like deliver like state-of-the-art experience for the customers. Sometimes it's evolution of some capabilities that already existed. So for example, we also apply machine learning within risk and compliance domain, especially on the risk side. As I mentioned, every transaction is screened on the riskiness and how it evolves naturally. So if company is small, company would have like small company that like start processing transaction, they will have maybe like 100 transactions per day or like 1,000 transactions per day. And, you can just manually like look if there's some suspiciousness happening there, which is fine, you don't need machine learning there. But then company grows, you have tens of thousands of transactions, you have like, start to having hundreds of thousands of transactions. You don't have, you cannot hire hundreds of people to like browse through the whole list of transactions and merchants that you have in your system. So you kind of start applying some rules. You start, putting like if, else, kind of like conditions, something else, which is fine, it's kind of growing stage that the company is at. And then you get to the point where you have millions and billions of transactions or some events. And then these rules start being not as precise because you company that is on that scale already, they probably expand to new merchant categories or new categories of business. They launch new products which cover, different segments of customers already. So whatever rules was placed before might not be applicable to where the company is at the moment. And it creates a lot of kind of problem of like what to understand, like what rules to set up. And that's where machine learning comes in as kind of like a natural evolution, because then it drives the precision of, for example, we want to create the best experience for customers, like on the transactional basis for risk, meaning that we want to allow as much transaction as possible and be as precise as possible to detect fraud early on and then stop it before it even happens. And that's where kind of evolution happens, and then experience improved, and also some of the metrics that we drive also improve.
So putting it together, does the models, how best to ask this, does it get easier the more data, the more experience the models go through, or does it become a problem because it becomes more and more complex?
It becomes easier. I mean, it's complex in the sense that you need to have like a lot of maybe like data science work behind it to really understand like what impacts the performance of the model, and then where you need to kind of already dive into details. So for example, when we talk about transactions, it's about behavior of like customers that are actual customers versus who's trying to commit fraud. And there's fraud patterns associated to it, like if, for example, it's a barber shop and, they process transactions. I mean, it would be suspicious if someone makes 10 transactions over like 2 minutes of like same person. I mean, I cannot imagine, one person 10 transactions in the barber shop. And but sometimes, it's like very like borderline. So that's why rules you might not be able to like put rules in place, but then machine learning would be able to spot like anomalies and like behavior which is associated with some of the previously known cases. That's why what I mentioned, very important is to have like a labeled data and labels. So then you can train your model on something, because then you understand what was the behavior previously. And in, for example, transaction fraud, it's like it's fraudulent transactions and all the data associated to them. And then based on such information, then you kind of can train your model, and then you can predict more better and precise in the future. So I would say it's more about like label data and labels for the models. That is very important.
Models tend to be more in the data science domain. So machine learning is a part of data science. It's probably the next step after a data scientist. How do we improve the environment for data scientists?
So maybe like in a way, machine learning is not just about the models, right? So it's a complex topic. So it's software engineering. You need to have like a services that make this prediction run in let's say real time. If you want to put it in like sub-second latencies, it's a lot of data pipelines and data foundations that are there to support all of these applications of machine learning. Because the actual machine learning is quite a small amount of work. Like most of the work is around like data engineering, data labeling, and some software engineering, and machine learning engineering. So all of that is kind of like bound together. And how we approach it within our team. So we really look into data scientists as also customers, just really understand like what are the needs of data scientists to really like productionize these models, or maybe they're missing some functionality to like build like features and like collect data or clean data. And it's a lot of different kind of actions that people need to do. And oftentimes like different company also approach it differently, but what we found the best is kind of enabling everyone to be able to do anything within like a platform. So for example, if someone wants to deploy the model, we want to enable data scientists and engineers also potentially, if they have interest or they have some great idea to deploy the model that brings benefit and improves customer experience, then they have all the tools and everything needed to make it happen. And it's kind of self-service. So, people just through like some how-tos guidelines, go through like few steps and make it happen. And that's how many companies approach it. For example, in Uber, there's Uber Michelangelo, which is like the center platform where also every data scientist has all the tools to like build the models, productionize the models, put them in real time or maybe not real time. Everything depends on kind of some of the use cases that they have. And other companies as well, like in Google and Airbnb. So everyone kind of gets to that stage, especially company really interested in machine learning and they want to invest in machine learning.
Nice. So not every company is Uber or Google, for example. So if we are working in a Berlin startup or a company that's looking to grow, how do we elevate, or what are the first steps to elevate the data science team within a company?
So step number one, build a foundation. And foundation is a scalable data platform that is able to handle like all these data transformations, collection of data, and like propagation of the data to the models as well. And if it's in real time, that it should happen like on scale and in real time. And for example, like also going back to some of the use cases. So like with the like transaction fraud use case and for risk, we need to aggregate a lot of data in the background. So let's say transaction comes and someone tries to pay. Let's go back to the barbershop experience, and someone wants to pay like 40 euros like in Berlin for like their haircut. So then you have like information such as amount. Probably you have like a understanding like what kind of like merchant category it is, which is the barbershop, and some basic information associated to this transaction. But that's not enough to make prediction. So to make prediction and understand like if it's actually like fraudulent or not, you need to have more data. And on the background, what like is happening is a lot of data is being processed and aggregated even before this request comes in. So then we already know that, for example, this customer maybe like did like 2 transactions over the course of last 30 days, or maybe on average they spent 100 euros per month or per quarter on like within the whole of SumUp ecosystem, which is deemed normal, and model makes prediction that it's normal, because there's also some other data associated to it that we already can see based on the historical data and all the data that we collected previously. So there's a lot of this foundation and pipelines that supply and provide a lot of this information on the background. So it's kind of like 2 processes in place, one which is happening in real time when the actual transaction is happening, and other that is happening behind the scenes, that there's a lot of aggregations and data transformation is happening with like ingestion of data from also maybe different sources at the same time. So building foundations with like a good data platform is step number one, because the rest is quite straightforward and easy.
Just on, where do anomalies come into play? So, for example, this customer has decided to treat his two friends to a haircut as well. So he's paying for 3 haircuts, for example. How does the process adapt to anomalies?
And that's where I emphasize the importance of labels and data that indicate that it would be suspicious behavior, because maybe no one, people previously also paid, in some way, like for 3 friends at the same time, which is totally fine, why not? But then if you put rules in place without machine learning, maybe, you will start blocking a lot of good customers in this way. So we want to avoid that. And for such reason, we need to have labels that associate with previously fraudulent activity. And if there was a fraudulent activity which associated with maybe not having like 3, but there's like a person who tries to make like 10 transactions at the same time, and that's minimum kind of like 4 based on the experience previously. And it's not only one data point, right? So there's a lot more other like data that being processed at the same time as well. So there's multiple, and all of them are being fed into the model. So that's why model knows based on this previous like cases and where the fraud patterns are. And that's why also some of the responsibilities of data scientists and analysts is really spotting and understanding like what is behind, some of these patterns, and kind of bringing in the most important data points. So for example, we also explored and we have use case around account takeover. So when, for example, someone maybe tries to get into someone else's account, and how to really spot if it's legitimate account holder or not. And then, you start seeing behavior which is unusual. Let's say, over the course of the day, usually someone will log in maybe 3 times, but then, within the model, you see that the behavior changes drastically based also on the historical data. And based on the data that we know previously that was maybe associated with such cases. And then it makes the prediction and like finds the anomaly or finds the kind of closeness to such previous behaviors, because anomaly it's not only anomaly, because anomaly is oftentimes associated to unsupervised learning. That's where you have no labels. So you don't know what happened previously, right? So you don't know if there was fraud or there was no fraud, and how would you even know that? And I would say unsupervised learning is very uncommon and not as precise, because you would not know what then actual cases are. And that's what we explored as well. But I would say the usual use cases when you have some data and that you want to train on, and you have these labels, and then it creates this precision, because then it knows already what happened before in the system, and based on the data points, you can kind of put the new prediction in place.
So do these eventually run themselves, these predictions?
Well, yeah. Model is baked into some service. It receives the request. And of course, ideally, we're in the modern world. There's APIs, and like you receive the request, and there's a response with like maybe some model score. So usually it's a redistribution of probability. So it's like a threshold, or like from 0 to 100, like what is the probability of this transaction being, like, let's say, fraudulent in our case.
Mm-hmm.
And then you will have like a scoring which is associated to it, and then you can make decisions and like really make decisions like in the service or somewhere like down the line. If let's say it's more than 90% probability, probably it makes sense that it's fraud. And usually the redistribution should be very, it's kind of like a dip, so there's a lot of those that deemed non-fraudulent, and there's a lot of those that deemed fraudulent. So then it's kind of normalized in a way that ideally we want to just have like 0 or 1, right? But oftentimes, there's maybe, as we discussed, like some anomalies, but it's not really anomaly, but there's maybe, not enough data to kind of make 100% precision. That's why it's kind of redistribution, and there's some that falls into maybe 70% confidence of, it being front. And then it's up to business to decide, if they want to stop more or they want to allow more of such transactions, and then see, based maybe on the performance and analytics, if it materializes in some fraudulent cases in the future, or, the precision was right, and then we blocked all the good, or I mean, all the bad actors in this case.
So to summarize, it sounds like we use data to help us. The evolution of data is to help us make better decisions. And we're getting to a stage now where with machine learning, the data is making decisions for us.
Yep, exactly.
Amazing. Well, time has absolutely flown. It's been an insightful conversation, Yev, about machine learning and some great use cases. We are going to wrap it up with a final question. So if we are looking to get into machine learning as a career, what can we do to explore in our spare time if we aren't within the data world currently?
Well, if someone is not in data world, I would suggest first exploring what is the data world, and which consists of data analytics, data science, data engineering, machine learning engineering, and general software engineering. And I would say really understand like where the interest or the most interest lies in. And I believe that anyone can really like go into any parts of, this ecosystem of machine learning and data world, as long as there's interest. And I think it's really to understand like where the closeness is. And for example, data analyst is a lot like working with actual like getting insights and working with actual use cases and with stakeholders and propagating message, when data scientists kind of like centerpiece between many of them. So then they oftentimes work with data hands-on. They need to understand cases. They need to kind of build models and kind of productionize these models. When software engineers maybe have kind of less exposure to like the actual business and the actual like use case associated to it, which I mean is also up to everyone. I think everyone needs to have access to everything, but I think it's where the person's more interest lies on. And then it's just go for it. And there's a lot of different courses and a lot of different information available online. So I think it's super easy nowadays to start this journey. When I only started my journey, I started as a data scientist, and it was hard because at that time there was no TensorFlows or any libraries that you can use. So I needed to build my own neural nets and things. That was a challenge. But nowadays it's much, much easier.
It sounds like you put in the hard work.
Yeah. But now there's so much information, so much learning material. So I would just say, as long as there's a interest and desire to grow in the space, there's always a possibility.
Yeah, it's becoming more and more accessible. So if you do have the desire, it's there to be explored, and it's not going anywhere. I think data science, machine learning is the end goal for a lot of companies. It's going to take a long time to get there, but it's a direction that most are moving. So
yeah, and also like a lot of these data platforms are built around architecture of like Microsoft or Google or AWS, a lot of different services that are used across like different organizations that provided by them. And they have so much information about kind of also data engineering, data science, analytics, and lots of information available and training courses. So I would say just pick in one and dive in details. It's kind of same concept everywhere, but just different tooling that different companies are using.
Sounds like you're telling everyone to take the leap and go for it.
Exactly.
Perfect. Well, you've taught us a lot today, and we could have spoken for a lot longer. I think these topics would lead quite nicely into a future podcast. We'd love to have you on again in the future, but that's all we have time for today. Thank you for your time and your insights, Yev. It's been educational. To our listeners, as always, drop any questions and feedback in the comments section. We'll pick out some to be answered on future pods. Don't forget to like and share so we can get the message out to as many people as possible. But it's bye from us. So thank you, Yev.
Thanks, Matt. It was really nice talking to you. Also, hope to talk to you in the future as well.
Fantastic. So to everyone, ciao for now.